everyone. We are ready to take a look at multiplying and dividing real numbers. This comes from section 2.4 and 2.6 in your textbook. All right, the very first thing that we want to do is review the sign chart for multiplying and dividing. You should have already learned in previous courses why these rules work. So we're just going to briefly go through some ways to help you remember these particular rules for multiplying and dividing positive and negative numbers. So the first thing you'll notice right off the bat is that both sides, whether I'm multiplying or dividing, produce the same sign answers. The same rules apply. So a positive times a positive is a positive divided by a positive is positive. If you're multiplying, a negative times a negative is a positive, and a negative divided by a negative is a positive. So an easy way to remember that is that if you are multiplying, dividing, and the signs are the same, your answer is going to be positive. The multiplying and dividing part is no different than what you've done in any other class, all right? So another way to think about this is if you're multiplying and dividing and you have an even amount of negative signs, your answer will always end up being positive, all right? The other situation that you can have is multiplying a positive times a negative or flipping it around and doing a negative times a positive. You'll notice that the signs are negative. Same thing with division, all right? So if you have different signs, one of each, your answer is going to end up being negative. Another way to think of it is if you have an odd amount of negative signs and you're multiplying or dividing, your answer will be negative. Let's use this a little bit in some problems. So let's take a look at number 7. In number 7, I'm multiplying negative 9 times negative 3 times negative 2.4. So what I'm going to do here, I always kind of, with multiplying and dividing, like to know the sign before I do the work with the numbers. If you put the sign down first, then you don't have to worry about it. So I'm going to go ahead and do that. Notice here I have 3 negatives, 1, 2, 3. That's an odd amount of negatives, so I can go ahead and put a negative sign on my answer. Another way of doing that would be to say, okay, well, negative 3 times negative 9 would give me a positive 27. And I'm going to multiply that by a negative 2.4. Okay? So a positive number multiplied by a negative number is still going to give me a negative answer. Either way you want to think about doing it. All right? Now, the multiplying part, that is no different. So, and actually when we multiply, we don't even use the signs. We just leave the sign off. And we go ahead and multiply it like we normally would. All right? So 4 times 7 is 28. We have to put the 8 down, carry the 2. 4 times 2 is 8, plus 2 would be 10. Going the other direction, remember we leave a placeholder here under the 8. 4 times 7 is 14, so we put the 4 down, carry the 1. 2 times 2 is 4, plus 1 would be 5. So when I add that together, I get 8, 4, and 6. I have one decimal spot, one decimal place in my problem, so my answer needs to have one decimal place. So my answer would be negative 64.8. Okay? Let's look at a problem with some fractions in it. So for example, in this problem, anytime we deal with fractions, whether we're adding, subtracting, or multiplying, or dividing, we always want to work with the improper form. All right? This problem, 2/3 is just fine. Don't have to do anything with that. I'm going to make my negative 15 into a fraction and make that negative 15 over 1. And then I'm going to multiply that by negative 3/4. Negative 3/4 is already a proper fraction. We don't have to do anything with that. At this point, I'm going to go ahead and figure out the sign. I have an even amount of negatives, so my answer is going to end up being positive. And you really don't have to put the positive sign when you're multiplying or in any answer that's positive. But the other thing that I want you to be good at doing, when you are multiplying fractions, it's the only operation where you can reduce in the problem before you get the final answer. So for example, in this problem, you will notice I've got a 3 in the numerator and a 3 in the denominator. 3 over 3 is equivalent to 1. So these are going to divide out because I'm multiplying. I'm allowed to divide them out. That's going to be 1 and that's going to be 1. You'll notice I have a 2/4. I divide both of those by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now I've reduced all the numbers. So all I'm left to do next is simply multiply the numerators. So I'm going to go 1 times 15 times 1. I've already figured out the sign. That's going to give me 15 in the numerator. On the bottom, I have 1 times 2, or excuse me, 1 times 1 times 2. That's going to give me 2. And then I will change that back to a mixed number, which would be 7 and 1/2. You get that by dividing. Okay? On to division. All right, so a lot of people know the rule for division, but I like to talk a little bit about why that rule works. Do you know how many 1/2s are in 18 wholes? So for example, and I'm not going to draw 18 pizzas, but if you had 18 pizzas, all right, and so on, and you cut them in half, how many halves, how many half pizzas would you have, or how many friends could you feed? Well, the answer to that problem, if you think about it, would be 36. Okay? So if we ask the question, how many halves are in 18 wholes, the answer would be 36. That really is the division problem, 18 divided by 1/2. You'll notice that in that problem, it doesn't really look like we divided at all. What we actually did was we really did the problem 18 times 2, or 18 times 2 over 1. All right? Now, what someone noticed was that if you have a division problem that involves fractions, that it is much easier to actually do that problem as a multiplication problem. So you're gonna, if you'll notice here, that dividing by a half does the exact same thing as multiplying by 2. To do this problem, I really would need to draw a picture, all right? But someone noticed a pattern that if we leave the first number, change the division to multiplication, and flip the second number, and this has a name in math, it's called the reciprocal, or if you look in your book, they call it the multiplicative inverse, big word, that you will get the same answer. So for us, it's important because we technically, every time we have a dividing fraction problem, we're really going to change it to a multiplication problem. Otherwise, we kind of have to draw a picture in order to figure it out. Nobody really wants to do that. So let's look at this in some examples. An easy way for you to remember this is something I call leave, change, flip. All right? So what it means is this. We're going to leave the first number. We're going to change the division to multiplication. All right? And we're going to flip or take the reciprocal of the second number. Leave, change, flip. It's a way to help you remember how to divide fractions. All right, so let's look at this in a couple of examples. So if I look at problem number 7, it has 17 divided by negative 2 and 1/8. So if you remember what I said from the previous slide, that no matter what operation we're doing, we have to make everything into fraction form first. So we're going to write 17 over 1, divide by, I'm not changing it yet because I'm going to get everything in fraction form first. In this one, remember you leave the negative off. 8 times 2 is 16, plus 1 would be 17. Put the negative back on, and now we're ready to do the problem. So we're going to leave the 17 over 1 like it is, change the division to multiplication, and we're going to take the reciprocal or flip the negative 17, 8. So this is going to be 8 over negative 17. Now I'm going to figure out the sign. I have a positive multiplied by a negative, or I have one negative. My answer will be negative. I'm going to reduce the numbers that I can. In this case, the 17s will divide out. 17 over 17 is 1. I'm going to multiply the numerators. 1 times 8 is 8. The negative was already there. We already figured that out. And 1 times 1 is 1. So my answer would simply be negative 8. All right. Another problem, again, using the same idea. So I want to first write everything in fraction form. So negative 3/4 a fraction, leave it alone. Divide by 4 over 1. I never do the leave, change, flip until everything's in fraction form. So we're going to leave the first number, change the division to multiplication, and take the reciprocal of 4 over 1. 4 over 1, the reciprocal of that is 1/4. Now I don't have anything to reduce because both these 4's are in the denominator, so I can't reduce them. So I'm going to go negative 3 times 1 is negative 3. I apologize for that pop-up. and 4 times 4 is 16. So our answer would be negative 3/16. If you want, you can try this problem, bring your answer to class tomorrow, and we'll take a look at it.